Algebra 2 5.4. Today we will be talking about another method for solving quadratic equations called completing the square. In the previous sections we have learned how to factor, and one of the methods that we have learned is called PST, factoring perfect square trinomials. We are going to need to know how to factor a perfect square trinomial in order to complete the square. By completing the square, we are forcing a binomial expression, meaning an expression with two terms, to become a three-term expression, so a trinomial perfect square. To complete the square, we take half of the b value and we square it. So in this case, our b value is 6, so we take 6 and divide it by 2, we get 3 and we square it. 3 squared is 9, so we add on 9 to our binomial expression. So our new expression is x squared plus 6x plus 9. So let's practice simply completing the square. X squared plus 8x. So this is our binomial expression and we want to force it to become a trinomial. So in order to do that, we're going to take half of our b value, which is 4, and we're going to square it, which is 16. And that's it. So in the next example, we're going to take half of our b value, which is 5, and we're going to square it, which is 25. In the next example, we're going to take half of 12, which is 6, and we're going to square it, and we get 36. Why don't you hit pause and see if you can get the next two examples on your own. Once you've gotten them, hit play and check your answers. Alright, so hopefully you got the correct answers. Let's move on. Now we said that when we complete the square, we're forcing it to become a perfect square trinomial. And the reason that we're doing that is so that we can later factor it. So let's practice some of these examples. So we're given a binomial, x squared minus 10x, and we want to complete the square. When we complete the square for the binomial x squared minus 10x, and this is actually the incorrect answer, so let me erase that, we get x squared minus 10x plus 25. So we've added on that third term to make it a trinomial. And now we can factor by taking the square root of the first term, which is x, the square root of the last term, which is 5. We take whatever this symbol is, in this case minus, and we square our expression. And now we've factored our PST. All right, let's go ahead and do the next example. So we are going to complete the square. So half of 22 is 11, and 11 squared is 121. So we're going to take the binomial expression x squared plus 22x, and we're going to add on 121. Now I can go ahead and factor this expression using the PST model. I can square root the first term, I get x. Square root the last term, we get 11. Whatever that symbol is goes in between, and we square our parentheses. So we've now factored that PST. Let's go ahead and do the last example. If I take half of 4, which is 2, and square it, we get 4. So if I rewrite this as a trinomial, I now have x squared minus 4x plus 4. And now we can go ahead and factor. Again, I'm going to do the PST model, square root the first term, which is x, square root the last term, which is 2, bring down this symbol, which is minus, and square the parenthesis. All right, so that's all there is to it. Let's take a look at what happens when our b value is not divisible by 2. So in this example here, notice that our b value is 7, and we take 7 just like we would take any of our other b values, divide it by 2, and then we square it. Now when we're dealing with numbers that aren't divisible by 2, it's best to actually not calculate the value. Just leave it written as 7 over 2 squared, and this will help later when factoring. So let's look at what that means. So over here, x squared minus 3x. we would be adding on 3 over 2 squared. Again, that's because I take the b value, I divide it by 2, and then I square it. So if I look over here at the next example, x squared plus 5x, my c value, since b is 5, would be 5 over 2 squared. In the next example, since my b value is 9, my c value would be 9 over 2 squared. And down here, my b value is 25, so my c is 25 over 2 squared. All right, now let's look at how that's going to help us when factoring. All right, in this first example, x squared plus x, we've taken our b value, which in this case is 1. We've divided it by 2 and squared it, and we've tacked that on to create our PST. Now, to factor, remember we take the square root of the first term. That's how we get x. Then we can take the square root of the last term, and when we do that, it's just that fraction 1/2. Then, just like before, we say, what's that symbol? It's a plus, that goes in between. Then we square our parentheses. All right, let's do some practice. So in this first example, if I want to create this binomial, or make this binomial become a PST, we're going to add on 13 over 2 squared. And then if I want to factor this, I would take the square root of the first term, which is x, the square root of the last term, which is 13 over 2. I would take my symbol, which is a minus, and I would square the parentheses. So now I have factored the PST. Let's go ahead to the next example. Here I would add on 9 over 2 squared, and then to factor this expression, we would get x minus 9 over 2 in parentheses squared. Why don't you hit pause and see if you can get the next one on your own. Once you have done it, hit play and see if your answer is correct. All right, so for x squared plus 15x, you would have added 15 over 2 squared. This is our PST. And then in factored form, we would write this as x plus 15 over 2 in parentheses squared. All right, so now that we know how to complete the square and then how to factor our PST, let's go ahead and actually use completing the square to solve a quadratic equation. So example number 1, x squared plus 6x equals 16. The first thing that is very important is to note that our variable terms have to be on one side of the equation, variable terms meaning the terms with our variables, and our constant terms, which are our numbers without variables, have to be on the other side of the equation. That is very important. So once you have done that, in this case it is done for you, you can go ahead and do the next step, which is to complete the square on the variable terms. So x squared plus 6x. If I want to complete that square, I would take half of my b value, which is 6, or half of my b value 6, and I would get 3. Then I would square the 3 and I would get 9. So I'm going to take 9 and I'm going to add it to both sides of my equation. Because remember, whatever you do on one side of an equation, you must do on the other side of the equation. So now that I have added 9 to both sides of my equation, I can simplify this expression. So I have x squared plus 6x plus 9, and I'm simplifying 16 plus 9 to get 25. The next thing we're going to do is factor our PST. Here, remember, square root the first term, we get x. Square root the last term, we get 3. This is a plus, so we have a plus in between our parentheses squared, equal to 25. All right, now we can go ahead and keep solving our quadratic equation. To continue, we are going to square root both sides of our equations. This will cancel out our exponent, So we are left with x plus 3 equals, remember when you square root something, it becomes a plus or minus, meaning positive or negative value. And the square root of 25 is 5. All right, now we can break this into two different problems. We have x plus 3 equals the positive 5, or we have x plus 3 equals the negative 5. We're going to go ahead and subtract 3 from both sides of our equation. X will equal 2. And if we do the same on the other equation, whoops, I don't know why I did that. I think I was just thinking the last answer. We're subtracting 3. So subtract 3, we would get x equals negative 8. And those are your two answers. All right, let's go ahead and do the next example, number 2. In number 2, notice that our variable terms and our constants are on the same side. We need to move our constant to the other side of the equation. So to do that, we're going to subtract 24 from both sides of the equation. Because remember, whatever you do on one side, you have to do on the other. So when we do that, we are left with x squared plus 12x equals negative 24. Now we can complete the square. So I'm going to take my expression x squared plus 12x, and I'm going to add on whatever my b value is divided by 2, which is 6, squared, which is 36. So I'm going to add on 36 to complete the square. Again, whatever you do on one side of your equation, you must do on the other. So if we added 36 on one side, we have to add 36 on the other. All right, now I'm going to add my negative 24 and 36. So we get x squared plus 12x plus 36 equals 12. Now I can factor my PST. That would be x plus 6 squared. Don't mind my dogs. Hold on a second. All right, x plus 6 squared equals 12. And I'm going to square root both sides. So I square root the left, square root the right. My exponent cancels. So I am left with x plus 6 equals plus or minus the square root of 12. Now, before we move on, we should simplify the square root of 12. Factor it, tree it out if possible. So let's go ahead and do that on the side. I know 12 breaks down to 3 times 4, and 4 breaks down to 2 times 2. Remember, for every group or pair of numbers, you can pull one of them out of your radical, and then the prime number that remains goes inside. So the square root of 12 is the same thing as 2 root 3. So I can rewrite my expression or my equation x plus 6 equals plus or minus square root of 12 as 2 square roots of 3. Now to finish solving the problem, we're going to subtract 6 from both sides of the equation, and when we do that, we get our solution. X equals, now put the minus 6 first. So minus 6, and then put the plus or minus 2 root 3. You cannot add these or combine them because they are not considered like terms. So this is our solution. X equals negative 6 plus or minus 2 root 3. This is an exact solution in simplest radical form. Unless you are asked by the directions to round your answer, you should not be using your calculator. All right, let's go ahead and look at example number 3. In example number 3, I need to get my variable terms on one side and my constants on the other. I am going to start by subtracting 8x from both sides of the equation. And when I do that, I'm going to subtract it from its like term on the right, which is the 15x. We get negative 2 equals x squared plus 7x. Now, I'm more comfortable with my variable terms on the left, so I'm going to go ahead and just flip this equation around. X squared plus 7x equals negative 2. Now we're going to go ahead and complete the square. So again, I'm taking 7 over 2, and since this is not divisible by 2, I'm going to just add on 7 over 2 squared. So I'm just going to scribble that side writing out for a minute, and I'm going to complete the square. So x squared plus 7x, and to complete the square, I'm adding on 7 over 2 squared. Remember, don't calculate it if it's not divisible by 2. Equals -2, and then here, don't forget to also add on your 7 over 2 squared. All right, once we do that, we need to actually, on the right, calculate what is -2 plus 7 over 2 squared. So I'm going to go ahead and type that into my calculator. -2 plus 7 over 2 squared. And I get 41 over 4. So I can now write this as x squared plus 7x plus 7 over 2 squared equals 41 over 4. All right, I'm now going to factor my PST, and when I do that, I get x plus 7 over 2 in parentheses squared equals 41 over 4. The next thing we do is square root both sides of our equation so that we can eliminate our exponent, square root the right side. Remember that when you square root a fraction, it's really square rooting the top number and square rooting the bottom number. So when we do that, we get x plus 7 over 2 equals plus or minus the square root of 41 over 2, because the square root of 4 is 2. All right, the last thing we do here is subtract 7 over 2 from both sides of our equation, and our solution is x equals, again, put the non-radical term first, which in this case is the minus 7 over 2, and then we write a radical term, which is the plus or minus square root of 41 over 2. Now, since both of these terms have the same denominator, it's actually best to write our answer as x equals -7 plus or minus the square root of 41 all over 2. So that would be the best way to write our answer, but both are correct. All right, let's go ahead and look at number 4. What happens if our a value does not equal 1? All right, this is going to be a longer problem. So just like before, we have to get our x terms, our variable terms, on one side. So I'm going to start by subtracting 6 from both sides of the equation. When I do that, I get -6 equals 3x squared minus 11x. Now again, I'm going to flip this around because I like my variable terms on the left. So 3x squared minus 11x equals -6. Now I need my x squared term to have a coefficient of 1. So we're going to divide everything on both sides of our equation by 3. When we do that, 3 divided by 3 is 1. So we are left with x squared. Now 11 over 3 does not simplify, so we're just going to leave it 11 over 3x equals -6 over 3, which is -2. Now we need to complete the square. Now we're completing the square for the 11 over 3. So if I do that, 11 over 3 divided by 2 is the same thing as 11 over 3 times 1/2, which equals 11 over 6. So I'm going to take 11 over 6 and we're going to square it. That's what we are going to add on to both sides of our equation. So now I'm going to go ahead and write that out. I now have x squared minus 11 over 3x, and now I'm going to add on my 11 over 6 squared equals negative 2, and also add on to this side of the equation my 11 over 6 squared. Now that I've done that, we want to actually calculate what is negative 2 plus 11 over 6 squared. So I'm going to go ahead, I'm going to extend the page just a little bit more, and for time's sake, if you want, you can go ahead right away and factor. So we have x minus 11 over 6 squared equals, and let me use my calculator to do negative 2 plus 11 over 6 squared. And let's see what we get. We get 49 over 36. So equals 49 over 36. Now you don't want to write this as a decimal. You want to leave these as in fraction form. Next thing we're going to do is square root both sides to solve our problem. Square root the left, square root the right. My exponent goes away. Remember, when we square root, we're square rooting the top and the bottom numbers. So what we are left with is x minus 11 over 6 equals plus or minus 7 over 6. The next thing that we need to do is subtract or add 11 over 6 to both sides of the equation. And when we do that, we are left with x equals, I'm going to put the 11 over 6 first, so positive 11 over 6, and then I'm going to go ahead and write my plus or minus 7 over 6. Since there are no radicals left in this problem, I'm going to break this into two problems. So one of my problems will be 11 over 6 plus 7 over 6, and my other problem would be 11 over 6 minus 7 over 6. So our two answers would be that x equals, let's see, 11 plus 7 is 18 over 6. And over here, 11 minus 7 is 4 over 6. So then we would simplify both of these solutions, and we would get that x equals 3 or x equals 2/3. And there we have used completing the square to solve our quadratic equation. Now yes, this problem is much longer when your a value, remember that number in front of our x squared, does not equal 1. All right, that is all for today's lesson.